So for today's first conversation, well, you have heard him talk the past couple of days, and as I said, he's leaving us on the 18th, and we're going to get a brand new set of conversationalists, so I'm really excited for you to meet them as well. But we are so fortunate to have had Professor Troll, because he is truly one of the world's leading volcano researchers, and he is currently a professor at Uppsala University in Sweden. So please welcome to the stage Professor Valentin Troll.
Thank you, Dave. Thank you so much for joining me this morning. And today I'd like to talk about, well, Iceland. We're going to Iceland, and certainly I'm very excited. I hope you are as well. And Iceland has been a mystical land for a long, long time, and I'm purposefully bringing up this old map. It's a Dutch map, and you'll see all these creatures, some more magical than others. And if you look very, very carefully, you actually get some useful information from that map. There is, for example, floating ice bears, polar bears, in some of the rafts in the top right. It's very small, I have to admit. But there's also the entrance to hell, which is Hekla in the center of Iceland. And then, let me see whether I get the pointer going. Yes, here, this is Hekla. So here's the entrance to hell. And there's some polar bears up here. Actually, here, it's very hard to keep steady. So here, you see a polar bear floating on an ice raft. It does still happen every now and then. Unfortunately, they have to be shot then if they end up on Iceland. There was one a year ago. And, but I'm not entirely sure about some of these creatures here in the bottom part of the map. They look a little bit fairy tale to me, but the impression that was given is, of course, that this is unexplored, unknown territory to a large degree. And indeed, Iceland is very rough and wild by comparison. So today I'd like to talk about how Iceland comes about, and I'd like to introduce you to the Champions League of the Icelandic volcanoes. And we're going to go through some of them, and then I'm going to try to convince you at the end that volcanoes are not all bad. There's a few good sides about them as well. So let's go in there. And, well, Iceland is pretty far north. It sits closer to Greenland than to the rest of Europe. And here we are traveling now towards Iceland. And Iceland is, well, it's called ICELAND, but actually it's quite a hot place. There's a lot of fire underneath as well. So I think it should be called Fire Iceland or Ice Fireland. But here we are. The reason for that is the mid-Atlantic ridge. And as I explained yesterday, there is something else going on. There is a plume coming on top of the ridge. So here we have Iceland sitting above the ridge. The ridge goes through the middle of Iceland, and this is where the Atlantic is spreading ever so slightly. We said it before, 2 centimeters a year. And this opening creates a lot of opportunity for magma to well up, to rise up, and this is what's happening along the mid-Atlantic ridge. In fact, 80% of all global volcanism happens on those ridges, submarine and not on land. Only a fraction of the volcanic activity is actually directly visible to us. So Iceland, it has a big rift zone going through the middle. Geologists divide it into the northern and the western and the central rift zone, but effectively it's one big system of cracking Iceland up. But the key question is, why is Iceland one of those view places where the ridge is actually visible above the ocean surface? And this is because we have a plume going underneath it. So here, a little reminder, we've looked at this yesterday, some of these fantastic fracture systems that we can study here on Iceland. This is where the plates are really breaking apart. And this breaking apart is going on for quite some time. The oldest rocks on Iceland are about 14 million years, comparatively young, and they are found on the very fringes in the most westerly and most easterly part of the island. And the spreading pushes them further out. So this is another bit of evidence for ocean crust spreading. And the most recent volcanic activity is, of course, in the center of those rift zones. In the little map on the right-hand side, the present-day situation is in the bottom right, and the more reddish color, that's the active systems, and the wine red color, that's it's the old systems that have been pushed away. And sooner or later, they will drown in the oceans, so they will also move further out and become part of the ocean crust, if you will. So this is what we see here, but I pushed the question before, why is Iceland above sea level? And that is because it has some magic support from underneath, and we have a mantle plume that's pushing it up. Various representation of the mantle plume exist, but I like this one. I share this one quite frequently with students as well. It's not too complicated, the one in the middle here, but it gives the idea there is this stem of hot material that rises up. Let me stress, it's not magma that's rising up, it's actually just hot rock, because it's under so much pressure deep inside the Earth that it doesn't melt. But it's hotter than the surrounding rock, and so over geological time, it makes its way upwards, like a super slow lava lamp, if you will. And only very close to the surface, about 100 kilometers before this material reaches the surface, that's when it starts to melt, because then the pressure is low enough. And once it melts, well, that's when magma is produced that then separates from the rising rock, because magma is faster, and then that's causing the eruptions at the surface. We talked a little bit about spreading of oceans, and well, we have good analogs for this. We have a reasonably good understanding these days of how spreading works. It starts off with continents that break apart, and we have examples like the East African Rift Valley, and then they spread further and further, like the Red Sea stage, and eventually we make an entire ocean. And in this particular case, in Iceland's case, we have this plume that exploits this spreading. So the plume is quite smart. It decides, I'm not coming up in the middle of nowhere where I have to push myself all the way through. The Iceland plume decided, I'll take this crack up there. And this is why we have this rather unique but very special combination of features. So the plume, and this is actually a representation from Athanasius Kircher. He was a monk in the 1600s, and he had big questions about how the Earth works. And he came up with this fire inside the Earth that then leads to volcanoes. So that was his idea. Only 50 years later, he was, at least people thought, he was completely discredited. People then started to think that volcanic rocks forms from ocean water. It precipitates from the oceans. There was a whole school about this, the Neptunists. And it was to people like Humboldt later on and Darwin to finally prove that volcanoes are actually produced from molten rock. So Kircher was actually further ahead than most of his contemporaries. But today we're still thinking in those terms, but it's not fire or magma that's rising up, it's hot rock. And you can actually picture that. And you do that by seismic tomography. Well, if you have a medical issue, then your doctor might send you for a computer tomography, and we can do that with the Earth as well. We can use earthquake seismic waves to check how the travel speed changes, and that allows us to say there must be areas that are denser or warmer than others. And when we do that, there's a fair number of those plumes in the Earth mantle, and here's different representations depending on the angle and which time you choose. But there we have several of those. And one of them is the Iceland plume in the top right. You can see it coming up in bright red. And this is just one of several of them, but it's the main one here in the North Atlantic. So these plumes are not infrequent. Hawaii is another example, and they come up from very deep inside the Earth. Just yesterday, I actually got a question from one of you, and it's about where do these plumes come from? How do they originate? And I thought it was a very good question. I usually discuss this with my advanced masterclass, so I'll bring it up now. Actually, plumes form from formerly subducted material. When you have material that's been pushed down back into the Earth, it has more uranium, because uranium is very big and it concentrates in continents. So this material goes down then again, and it brings the uranium down. And what happens to uranium over geological time? It decays. It decays to lead, several leads, and that produces heat, radioactive heat. And this creates the heat anomaly for those plumes to come up. So when you look at Icelandic rocks, there is actually a tiny bit of recycled former material from a continent that's lost for literally hundreds of millions of years, and the Earth is bringing it back up. So that's how plumes originate, and that's why they're a bit anomalous. We have an area down there at the core mantle boundary that people refer to as the lithosphere graveyard. So not an elephant graveyard, but a lithosphere graveyard. So here the subductive material comes down, it starts to get stored, and after a while it had produced so much heat that the material starts to rise up again, mixes with the ambient mantle, and that's what's causing plumes. And well, the simple way to look at this plume is a stem of hot material rising up, like I'm showing here on the right-hand side. On the left, it's a bit more of a complicated diagram. It shows the anomaly is actually not that simple. It's a bit windy, and it pushes its way up in a more convolute fashion, but the concept stays the same. So now I'd like to move a little bit down onto the ground when it comes to Iceland, and for that I need to give you a very brief introduction to volcano magma systems, as we call them. Well, the cone that you see at the surface, that is only the tip of the iceberg, if you want, because there's a whole supply system of conduits, of magma reservoirs or magma chambers, of magma pockets. They interact with each other. They can spread laterally or oblique, and they form a plumbing system, a magma plumbing system, as we often refer to. And this is what you can, of course, study in eroded volcanoes, and the link of them with the surface volcanoes then becomes clearer when you understand the plumbing of the magma supply. In Iceland, we have about 30 larger volcanic systems, and there is a distinction between central volcanoes and fissure volcanoes. I'll explain that in a minute, but all of the active systems, they cluster along the main rift axis. So it starts here with a submarine Reykjanes Ridge, and this goes on land here in the Reykjanes Peninsula. That's where we have the current eruptions going on in this part, and I'll talk about it this afternoon. And then it forks here a little bit, but then it leads into the northern rift zone, and there's also the southern rift zone, and that's where all the main active volcanoes are. So I'll try to introduce you to the key volcanoes now, so that you have an idea of the Champions League of Icelandic volcanoes, as I like to call them. And here in yellow with red margins, that's the central volcanoes. That's the big boys of the volcano club there in Iceland. And there's some smaller ones as well. The big ones are usually central volcanoes. They are multi-genetic, so they form over many eruptions, while these fissure swarm eruptions, they usually are single event. The event can take years, but they are usually a single thing. They're not pausing for 200 years and then coming back. They are once-off features, and they usually don't build up large volcanoes. So I should also say a word about hazards, because we'll mention some of the problems when I introduce these volcanoes. Well, there's different hazard scales, time scales, but also distance scales. And there's direct effects from volcanoes and indirect and more distal effects. So, of course, there's effects on the basis of hours, minutes even, where we have lava flows, glowing avalanches when the volcano is explosive. We have ashfall. Ashfall is also instantaneous, but it can travel further away, so with a delay effect, it can reach other areas where it can cause big problems, respiratory problems for populations, clogging up drainage systems, etc., collapsing roofs because of overload. And then ultimately, all the ash can cause climate effects as well. It's not uncommon that after large explosions, we may actually have a little bit of a dip in the global temperature for 2-3 years after such an event. So, but now, here, let's start. We're starting in the very west of Iceland, and there is a little peninsula, the Snæfellsnes Peninsula, and there is a big volcano, Snæfellsjökull. And Snæfellsjökull is a special place. I was there as a very young researcher, and I was looking desperately for that place that Jules Verne describes, because apparently that's the entrance to the center of the Earth. So Professor Liedenbrock went there with his team, trying to find the entrance, and finds it indeed, and goes down into Snæfellsnes volcano. And does anyone know where they come back? Well, I'm saying it here at the bottom of the slide. They come back out at Stromboli. And the important implication is that Jules Verne implied that the volcanoes are connected somewhere in the bowels of the Earth. Well, it's a little different. Stromboli and Snæfell's Jökull, they're not directly connected, but the idea was very kind of intriguing, and I give him a lot of credit for that. So Snæfell's Jökull, and it's been rumbling recently, so there has been earthquakes, and we have no historical eruptions, but there is a possibility that it might wake up in not geological time, in actually our lifetime. So let's see about that. So then we can move a little bit further down to the Reykjanes Peninsula. This is the active system that's going on right now, and it started off about 4 years ago, in March 21, when suddenly earthquakes happened on the Reykjanes Peninsula, and the last eruption there was 800 years prior. So for 800 years, nothing happened there, and this is why people built power plants and airports and all that kind of thing. And Reykjavik is very close to it, and the eruption kind of started as a Disney volcano, as many called it, because it was nice, it was in the mountains, there was nobody living there. You could see it from Reykjavik, it was spectacular. And at the time it was COVID as well, so people kind of took a real interest, and actually some people argue that the volcano saved Iceland, because tourism is a huge industry in Iceland, and COVID was very problematic. So here's a few impressions, and indeed here the point is made, a volcano that saves Iceland's travel industry, because many people flock to it. In 22, at the first day of the 22 eruption, 10,000 people were at the volcano. Can you imagine? And the Icelanders were quite relaxed about restrictions, because they wanted the tourists to come. So you could actually go there, and there's videos on YouTube of people, I don't know, frying sausages or doing really silly things. So, and well, nobody got injured, at least early on, so all was great. And the volcano kind of, yeah, here you see people kind of having almost a party out there at the volcano eruption. The lava was reasonably slow, so you could walk away from it, and this was a big thing at the time. So this was a year later, in 22, a new little volcano popped up just a few miles to the north, and this is then, yeah, us kind of making an effort to get some lava samples there, and I'll talk more about this afternoon. And here by now we have a second lava field in December 23. Suddenly a big earthquake happened in November, and in December new vents opened up a little bit further towards the west at Sundnukur, and that's when things got more serious. Suddenly there was lava right next to the Blue Lagoon, the biggest tourist attraction in all of Iceland. And the Blue Lagoon, as some of you probably know, is actually the wastewater of the Svartsengi geothermal power plant. So suddenly you have a tourist attraction and a power plant next to a volcano. Not to mention the village of Grindavik, which was one of the main fishing ports in that part of Iceland. So suddenly the Disneyland volcano has become rather nasty. And here's a few impressions. The Icelanders are working really hard to put barriers up to protect the town, to actually with quite some success, to quite a degree of success. But every now and then the volcano decides, I don't care about your barriers, and starts to erupt inside the barriers. So as was the case in early 24, and here's a bit of lava in the town of Grindavik, and it's, yeah, not a nice sight. But that's the reality of living close to an active volcanic system. So here's a few more impressions, and I always show this image on the right-hand side because I'm always so fascinated. If I was a businessman in Iceland, I would try to sell these wooden fences as being lava resistant. So, but it's a sheer coincidence, of course. So but it looks fantastic, doesn't it? So let's move on. The next big volcano there is Hekla, and I mentioned Hekla earlier. Hekla has been widely described, certainly in medieval literature, as the entrance to hell. Partly this was motivated by the Icelanders being a little late converting to Christianity. So most of the writing in continental Europe was done by monks, and they wanted to portray this as a really bad place. So there was a little bit of a political motivation there as well. But Hekla has big fumaroles on top, so it does smell like sulfur, and it's got big yellow encrusting on the peak. So it's not entirely kind of wrong to get the impression that this is not a nice place. But again, I don't think it's the gateway to hell or the Earth interior. It's just a volcano, but a particularly prolific one. And the last eruption was there in February 2000, producing a nice lava flow that you can look at and sample if you get by. But so far, there was a little bit of earthquake activity, but right now, Hekla seems quite at peace. So, Heimaey, that's where we're going right now. And Heimaey is a little island in the Westman archipel, and this just sits at the south of the southern rift zone. And, well, where does the name come from? Westman was actually the Viking or the Norse name for Celtic people from Ireland. And the story is actually not so nice, because apparently some Irish slaves were not so happy with their Viking master, and they killed him. And they realized pretty quickly it was not the best of ideas, and they ran away. They escaped to this little island. But, well, I think it was the brother or the son, but somebody from the big Vikings family decided that's not gonna go on. And he mounted an expedition. It took him 2 years to get all the resources together, but he went out to the islands. And that was the end of the Westman people. So the islands are still named in commemoration of this event. So another event that happened there was a pirate attack. Actually, pirates from North Africa came there in 1627 and captured a whole shipload of people to enslave them in North Africa and sell them on the slave markets there. And so it's been quite an intriguing place, and not to forget the big eruption in 1973. I was just tiny, and the eruption was, however, already on the television, and I remember this vividly, that I could see some of these images. Of course, I had no recollection where this was, but when I see some of the images today, I remember, oh yeah. So Heimaey was a big thing because a volcano, the Eldfell volcano, sprung up right next to the town. Well, that's one of these Icelandic problems, isn't it? So here we have Heimaey, and the harbor is one of the main lifelines of the town, and you can see the harbor basin there. And just in the background, you can see the lava. Here, that's the one, sorry. So this is the lava from the Eldfell volcano. And the problem was that it threatened to close the harbor off. The volcano is actually here. You can see the slope here. So it goes on towards the right of that image. And that erupted 1973, sending lava not only but mainly to the port area. And the big worry was that the port will be, well, destroyed and closed off. Here's an aerial image from 1973. You can see where the lava reaches the water. It starts to steam up, of course, but the risk was that this would actually be a financial disaster for the island. And, well, the story goes that there was a big effort, and there was big pumps coming in from the US, and they put them on ships, and then they were pumping seawater on the front of the lava flow in order to cool the lava so that it would stop. And it stopped. And since then, the Icelanders claim they can stop lava. It's a little more nuanced than that, I'm afraid. I mean, if the volcano comes with a lot of lava, there's nothing you can do. We had this example in La Palma, in the Canary Islands, just 3 years ago. And there was a little church, and the lava came, and the local villagers believed they can do an Icelandic trick. And all the geologists said, no, it's not going to work in this particular case at all. And indeed, it didn't. The effort was in vain. The church was drowned in lava just very quickly after the ditches were dug and the walls were put up. So the thing is that a little bit of water spray will harden the crust on the lava, of course, but there's a lot of new lava coming. This will not make a huge difference. So You can have a little bit of an effect, but I think the volcano decided to, okay, it's good enough now, rather than the Icelandic water spraying effort. So, but I'm happy to discuss. So here's a few more impressions from 1973, and there you see a lot of ash also on the roofs of the houses. There was also some phreatum magmatic explosions. That is an explosion when lava and water come together, because we're on an island, and then you get these steam explosions, and that's also what we witnessed there. And talking steam explosions, they're often in the community of volcanologists referred to as Surtsayan eruptions or Surtsayan explosions. That goes back to 1963, when in the Westman Islands, very close to Heimaey actually, a new little island sprung up, Surtsey. And Surtsey, well, there's a lot of water on top when the magma is coming up, and there was a lot of these phreatic explosions or Surtsayan style explosions. So here's a few spectacular images from that. And Surtsey is now about 100 meters above sea level. It started in late 63, and the eruption lasted actually until 67. So it had a bit of time to build up, and that's very important, because islands are actually notoriously unstable geological features. So Surtsey was building up long enough to actually be around for a little while. And here's a few more impressions. And just last year, we wanted to go to Heimaey here on the Sojourn, but we couldn't because of bad weather. So the captain decided to circle around Surtsey. So I got some great images from circling around Surtsey for a day in the clouds. Anyway, I'm saying that these islands are not very stable, and where is that statement coming from? It actually comes from this place here. In 1831, there was a new island forming in the Mediterranean between Sicily and Tunisia. It just sprung up. And well, back then, this was a strategic wonderland. And within a few days, everybody put a flag on it. The Italians put a flag on it, the French, the Brits. Everybody gave it a different name. And the French called it Il Giulia, or the Italians called it Fernandina, and the Brits called it Graham Island. And there's even plaques that were put there, and you can see one of the plaques down here claiming the new land for this particular country. The problem was that a year later the island was gone. Wind and waves took it down, and maybe it subsided a little as well, but bang, the island was gone. So Surtsey is a special case because it's still there, and we just drilled into it as well, so there's a lot we're learning from Surtsey. Unless there will be more eruptions at Surtsey, it will go as well, but here's our understanding of how an island like this forms and emerges, and then if sustained eruptions occur, this will build up into potentially a larger island, or if that doesn't happen, it will decay into a seamount, a submarine mountain that is not actually visible on the surface. So then, well, we all have to face that. Eyjafjallajökull. And Eyjafjallajökull is the big volcano that erupted in 2010 and caused all the air traffic closure. And Eyjafjallajökull is, it's a funny name. We all struggled with it at the time. But Eyja is island, Fjalla is the mountain, and Jökull is the glacier. So it's actually the glacier on the mountain near the islands. That's how the name comes about. And the islands are the Westman Islands because it just sits on shore from Heimaey and Surtsey. It's effectively the onshore continuation of this volcanic chain that we see there, and it's reflected in the name, the glacier on the mountain near the islands. And it erupted in 2010. It actually erupted quite calmly for the first few weeks, and nothing much happened. But then this magma must have hit something else. We believe there was an old pocket of magma from the previous eruption inside the volcano. And there was an eruption in 1824, and this magma must have been stewing there. It was probably quite viscous, like cold honey, but it was probably very gas-rich because all the gas had accumulated. And when the upcoming magma hit that pocket, that's when the whole kind of explosion started, pumping ash high into the stratosphere, causing all the problems for the air traffic. Let's see whether I get this video to go. So that's how it looked. So, and this is a more distant feature, and you see the ash cloud and the ash raining out, and if this is pumped high up, then, well, it's a little difficult to fly through things like that. And have you ever heard that story from Galunggung from the 1980s? There was this crazy situation. A British airline airplane was supposed to go from, I think, Singapore to Sydney. And it was flying over Java in Indonesia. And it was a night flight, and they hadn't a lot of vision, but suddenly they hear these crackling sounds on the screen, and everything scratches up, and they couldn't see anything anymore. Suddenly, visibility was poor anyway, but they realized something weird is happening, and then one engine drops, the second, the third, and suddenly nothing goes. And they realized, whoa, we're not making it to Australia. So they call for emergency, and they say, yeah, you can actually fly to, what's the nearest airport? Oh, it's Jakarta in Java. And they say, okay, we'll go there. And then one of the engines came back. Oh, we can actually make it. So they turn around and flew back, and they realized that not only do they have they flown through an eruption of Galunggung volcano once, they actually went back and flew through it twice. So these are heroes, of course, in the volcano world. But from that experience, we realized it's serious when we have eruptions like this. And this is what caused much of the caution in 2010, the 1980s experience at Galunggung in Indonesia. So we had that video. And was this a video? Let's see. This is a slow one, yes. So, and what I want to show here, see the bombs coming out? See these fragments flying out? I'll do it once more. So just at the bottom right of the eruption cloud, there's these big fragments flying out. Yeah, you don't want to catch them. So anyway, and this caused a lot of problems for air traffic, and part of the issue was that it affected what's known as the blue banana. The blue banana is the economic heartland of Europe, and it's down here in this little thing. So here we have the blue banana. It's the Rhine area and the Rhone area going into the Netherlands and then into Britain, and this was all affected by ash, so it really curtailed the traffic in that area, and therefore the communication, and therefore the economy, and it was a big financial disaster. Nobody died, but the financial aspects were quite grim. So we really have to do a little bit more homework and get ready for events like this in the future, because it could happen again. So this was the experience there, and right next to Eyjafjallajökull is Eyjafjallajökull's big sister, Katla. Katla is much larger. Katla has not been erupting since 1918, and then only in a small eruption. That's the image in the top left. That's the 1918 eruption. Very few images. This is one of the few, and somebody colored it in with watercolors. It's not the original colors either, I'm afraid. But yeah, there we have a big glacier sitting on top of a caldera. A caldera is a depression, a volcanic depression like Yellowstone. And this is about 14 kilometers across, and Katla has been erupting quite frequently. It's also one of the main CO2 emitters. Current estimates are that it produces about 4% of the global volcanic CO2, so it emits CO2 all the time. But make no mistake, volcanic CO2 is dwarfed by human CO2 output. So people often say, oh, could volcanoes cause all the things? Only if there's a lot of volcanoes erupting at the same time. Yes, then they can do that. So here is an impression. The little ice cap over there, the tiny one, that's Eyjafjallajökull. That is Katla. So this is a lot bigger, and there was a big worry back then in 2010 that Katla might wake up as well when Eyjafjallajökull was erupting, but it did not. There was a few earthquakes, but many people claim Katla is overdue. But I don't personally feel so strongly about this claim. I think, of course, we could have an eruption, but we don't know how big it will be. It could be a comparatively small one. I would be a little hesitant to make this too much of a claim right now. But is it an active volcano? Of course it is. Can it erupt? Of course it can. But it doesn't have to be a huge eruption every time it erupts. So what you can do if you are around there, you can actually go up the glacier, and there's glacial caves, and there's tours up there. Quite spectacular. So you can actually be in the ice on top of a volcano, and maybe you feel a little earthquake as well if you're lucky. So next to Katla, we have the Elgjá fires. Oh, Elgjá is a funny place. Elgjá, Eld is fire in Icelandic, and Gjá is an old valley, so it's the fire valley. And there we have the fire valley that erupted in the 930s. There was a big discussion when exactly, but after these eruptions, there was no more Viking settlers coming to Iceland. It stopped the settlement period. People were realizing this is not as cool a place as everybody says. So, there was this eruption for several years. It was a fissure eruption, and apparently it was very bad because it caused several nasty winters, three nasty winters in the subsequent years. And it's believed by some scholars that this could have been the inspiration for phrases or passages in the Edda, the rule book of the Vikings, and where they also kind of record their beliefs in terms of the Aesir gods and how the end of the world will potentially look like. So when the Elgjá erupted, there was this winter period afterwards, and this is actually also described in the Edda, that there will be the Fimbul winter, a long winter just before the end of the world. And apparently it takes 3 years, according to the Edda, which is a striking coincidence. The Edda was written about 100 years after the Elgjá eruption. So, and there's descriptions in the Edda that I think sound like volcanic eruptions. So it reads there, there will be a winter with great frosts and keen winds, and the sun will do no good, and there will be 3 of these. So there is some passages that remind me of these effects, and the next one is even more striking. The sun will turn black and land will sink into the sea. The brightest stars will vanish from the skies. Fire will rage forth and the flames will lick the heavens itself. Boulders will slam together so big that trolls will tumble, and man will tread the path to hell. So this is a big volcanic eruptions, and I was very keen to show you the big boulders that were coming out of Eyjafjallajökull, because that's what I think is meant here, because that's the only force that can do that. Well, this could be all fiction, but we have an independent source, and this is from the Saxon Chronicles from northern Germany, and there King Heinrich was about to die, and he was the first Saxon king after the Frankish kings. And it was very important in the Saxon Chronicle to highlight that everything, even the earth, was mourning. So there is a passage there that says, in the years just before the death of King Heinrich, which was in 936, many signs occurred. The mountains of the north are said to have erupted in flames in many places. Also, the brightness of the sun itself seemed to diminish. Well, there's a link probably between those two things, but there we have a good reference now, an independent reference that did confirm that there was big eruptions at that time in this part of the world. So, a relative of the Elgjá is the Laki fissure, and just a little younger. In 1783, Laki erupted, and it's a fissure in southern Iceland, and it produced a really unpleasant cloud of poisonous gas, and this poisonous gas was very fluorine rich, and it traveled towards Europe. It also poisoned many of the fields there, and it led to a lot of the farm animals perishing, and as a consequence many of the people suffered, and it led to crop failures also in Europe. So there was a famine after the 1783 eruption in Iceland. It's believed that about a quarter of the population perished as a consequence of that, and that would have been about 25,000 people at the time. Population density was of course, very low, and this is why this event was even more severe when you have few people and then many of them die. So this was a big problem. Askja, we're now moving to the north and we're almost done, 2 more volcanoes to go. Askja, well, Askja is a very strange place. It's also a big caldera volcano, and I remember a few years ago I was having the time of my life up there. I was in August on Askja volcano, and suddenly it all goes cloudy. I couldn't see a thing. And it started to snow, a snowstorm in August. So it got so bad that it was the first time in my career that I had to take my absolute super emergency glucose tablets out, because I was so shivering and I was so out of even orientation and strength that this was actually really necessary. 10 minutes later, I got my strength back. The glucose did its job, and I was able to make my way out of the clouds in the end. But I have quite a lot of respect for Askja. So Askja is a dangerous place. And it erupted in 1875, and not in a pleasant way. It has also a big acid lake. There's an acid crater lake, and big worries are that if there's an eruption, it actually may spray the acid around. So, the Askja 75 eruption was severe, and it caused a major wave of immigration of Icelanders to the US and to Canada. And the ash and tephra was actually blown again to Europe. So there is a lot of records in Sweden, for example. In southern Sweden, they kept meticulous records. So the 1783 eruption and the Askja eruption are both linked to higher mortality rates, even in southern Sweden. It's just a few percent, but there needs to be an explanation for that. Now, the other intriguing thing is that when you look at where Icelanders went in the US, I found that some of them liked the cold. So here is the map, and this is where Icelanders went to settle. So some of them are here up at the Canadian border, some of them here. And then there's also a group of Icelanders that decided they're sick of the cold. So they went down here. So very funny, I thought. Very little in between, but here we go. So the last volcano I'd like to introduce you is Krafla caldera. And Krafla is famous for a big geothermal power plant. And a few years ago, they drilled a new hole for getting hot fluids out. And oh dear, they drilled into magma. They had no idea it was there. It was a small pocket of magma, but the magma was happily sitting there, probably like the 1824 pocket in Eyjafjallajökull. Nothing really happened. Well, the drill was gone. It was very expensive, but no explosions or so. And there was a big series of eruptions in the 70s and early 80s, the Krafla fires producing wonderful lava flows in the area. So it's a very active system. And now there is a big effort by a colleague of mine, and he wants to get big pennies from the European Union to actually drill into the volcano again, but this time purposefully. So good luck to him. So I'm curious whether the EU will pay for that, but yeah. So having introduced you to these big volcanoes, I should also point out these days all of them are monitored. So there is good installations for checking out what the volcanoes are doing, and we usually know a little bit in advance, often quite a bit in advance, whether a volcano is gearing up for an eruption or not. We measure things on the ground. We measure the deformation, for example, but also the heat emissions, temperature changes. We look at the gas composition, and increasingly we're using also remote sensing. We're looking at satellites, for example. So if you have a satellite going over an area multiple times, taking a shot each time, you can do these little kind of maps that I'm showing in the bottom right. This is a little deformation map. So you get these kind of rings of deformation. If you superimpose these images, then you can see something is happening. And obviously, it points you towards a major source in the center of this particular image. And this can be done, well, almost at the site, because the satellites are out there anyway. So, but the two faces of volcanoes, I promised I'll say a few good words about volcanoes as well. Because personally, I think, like everything on this planet, nothing is ever good or bad exclusively. There's often two sides to things. My Spanish colleague, he always says that there's nothing bad that isn't also good for something. So I would like to kind of help the Volcano street cred a little bit by kind of giving you a few other aspects here. So, well, volcano tourism is really hot, isn't it? I mean, 10,000 of people at the first day of the 22 eruption. People want to see this. And I remember having seen my first eruption. There is something. The Earth is not as stable. There's some vibration you pick up. Animals pick it up as well. They run away. But of course, I go closer. And there's a sensation about this. So I can see why people want to go there. It's weirdly exciting, I find. And there's, of course, another set of things coming from volcanoes, like the Blue Lagoon. I mentioned it, but the Blue Lagoon is also a major industry now because it sells a lot of cosmetics. If you're in Reykjavik at the airport or so, you'll come to see the Blue Lagoon shop with all the kind of special products they have. So, and let's talk a little bit about geothermal energy as well. Was this a video? Yes, it was. This is from Krafla, actually. This is one of the geothermal fields, and there you have a degassing site. And of course, we can harness the energy from these upcoming hot gases, and we can use them, as the little plot, the pie chart shows, we can use them to make electricity, but also just to heat space. And in Iceland, swimming pools are heated with this, but also snow melting and fish farming and greenhouses. All of these things are using geothermal energy. And actually, there's a big aluminium smelter in Iceland as well. This is not a place where aluminium ore occurs. And the aluminium ore is actually shipped in to Iceland from other places. It's smelted there and then shipped out again because the energy is so cheap in Iceland. So it's worthwhile doing this. Initially, it came, I think, all the way from India, but they stopped that now. I think it comes from Spain now, I was told the other day. But still, Iceland is smeltering this, and now they're thinking about building more smelters. But of course, there's also a lot of resistance towards that. So how do the geothermal power plants work? Well, the idea is that water is getting close to a heat source underground, and then it's converted to steam. That means it's increasing in volume, and that can drive turbines and things like that. So you can then make electricity from that. And what you do in geothermal power plants is you're not just waiting for things to come up, you're actually pumping water down into the right spot, and then it gets converted, so you can control the process to a certain degree. The model goes back to a Vairaki power plant in New Zealand. This was done in the 1950s. The Icelanders copied it, and it's now a very successful model. There is a large number of new power plants springing up in Indonesia, the Philippines, etc. And this is an intriguing but very relatively clean way of energy production. But you kind of need a volcano close by. So, more use of geothermal energy, I mentioned it. Snow melting in Iceland. Many of the main roads actually have pipes underneath them. So, not only is that hot water supply, it's actually also kind of keeping the roads ice-free. And you can do all sorts of heating with it. You can heat greenhouses, as I said, but you can also dry fish in those places. And dried fish is very popular in Iceland, obviously. So, if you get some dried fish, chances it was dried with geothermal energy. And I should point out that farming is actually a big thing. Iceland is not in itself a farming place. It's too cold and wet and too rocky. But right now, actually, Iceland is the biggest producer of bananas in all of Scandinavia. And well, it's not a big feat, but but that shows you something. So it's grown in greenhouses, and there you can get some idea. In the little plot down there, there's different energy sources that are used in Iceland, and the big one is the geothermal one. And since the 1960s and 70s, geothermal has become the main energy source in Iceland. So, and of course, there is byproducts, and one of the byproducts is that if you have a lot of this water coming up, you need to get rid of it. The Svartsengi power plant in the top right had this problem as well. They were pouring the water into the landscape, and little lagoons happened to form, and the Blue Lagoon was born. So, and now you can go there and have a relaxing bath and buy some cosmetics as well. It's apparently very good for your skin. And I did try it. I couldn't feel a big difference, but some people claim it's amazing. So, and here's another use of Icelandic things. This is one more to my taste, and that's actually whiskey stones. So here you can use Icelandic basalt cubes. You can put them in the freezer and they're nice and cold. You put them in your whiskey, then it's cold and neat. So here you go. Anyway, just to close off, Iceland is also, and the volcanoes are, of course, important for not just our pleasure and the resources, but imagine all these landforms and life forms that we see and all the things we learn from studying those things in Iceland. Many people, many geologists claim Iceland is like the first continents when they formed, so it's like a glimpse into early Earth, if you will. And I agree, Iceland is an extraordinary laboratory for science, and this is why I am going there so frequently. Thank you very much for your time.